Hello, my name is Fernando Lucena. In this video, I will make a presentation of the Aconcagua Integrated Development Environment. This application has been developed by me as a tool for programming FLC scripts. This presentation is organized as follows. First, I will make an introduction about the application and its main characteristics. Then, I will show the different parts of the application and its functions. After this, I will introduce its file management capabilities. In the next section, I will teach all its rich edition features. Then I will explain how to execute programs. Following, we will see its debug options. Then I will show how to configure the application. And finally, I will indicate how to run a script from the command line using the FLRun application. The Aconcagua Integrated Development Environment is a standalone application that allows edit, save, execute, and debug FLC programs connecting different database providers. Even if it's possible to edit FLC programs using any text editor, this is a unique tool to debug them. In this video, I will present the tool itself and not the language filters. There are other videos dedicated to this topic. Its main advantages are: it does not require any additional software installed in your computer. Most applications need some libraries to run, like the Java Virtual Machine, the Microsoft.NET Framework, or some DLL files. Because it's a simple executable file, it can be downloaded and executed directly without any installation process. Also, you can delete the executable and its configuration text file, which is in the same directory, and there will not be any trace on the computer of its use. The application does not make any modification to the environment variables or registry nor install additional files. As I explained it, the application allows connecting to all major database providers. Of course, the client library of the database must be already installed in the computer. This application can be run on the three main operating systems: Windows, Linux, and Apple OS X. There is one version of the application for each environment. The application has four main elements. The editor panel allows writing plain text programs like Notepad does. The debug panel includes all the debug tools. It has subpanels and tabs to show variables value, functions tag, messages log, and cursors and text file contents. The menu groups its item in File, Edit, Macro, Run, and Tools. Most of the commands have its corresponding tool button and shortcut keys. Finally, the status bar shows messages, the database connected, the user, the run indicator, the cursor position, and the next statement to be executed. The application manages plain text file with the FLC extension. It can edit one file at a time. The file management command includes the standard operations: open, save, save as, new, and print. The file commands are in the first menu item and in the first group of tool buttons. The application only allows to open file with the FLC extension. The name of the current file is always in the title. If the file is modified, the Save button becomes enabled and a star is added after the file name. When the file is saved, the star disappears and the Save button becomes another time disabled. If the file becomes modified by another application, the editor detects it and proposes to reload the updated version. The file can also directly open using the file manager of the operating system. The application has rich editing features. They can be classified in find, indent, undo, and macros. I will also talk about syntax highlight, bookmarks, and autocompletion. There are four find commands: find, replace, and other two to repeat the last find operation forward or backward. If the cursor is positioned over a text, the application will propose to find it. The command allows to find partial or complete words, be case sensitive, and execute the search forward or backward. After perform a find, it's possible to repeat the operation without calling the find form each time. The application can indent or unindent text using 2 spaces each time. You must select the text to be indented. The editor automatically indent text, align new lines with the previous one. At Aconcagua, we have some strict coding standards. One of them is to uppercase all the SQL reserved words. To accomplish this and speed up the editing, the application has a special button. The macro features register all the preset key, characters, cursor navigation, text selection, and copy and paste operation. For example, to copy the value of a cursor into another one, we can copy its column and record a macro. The application can perform until 100 undo operations. They can also be executed after saving the file. The application highlights text to help the codification using different colors and styles. All language reserved words are dark blue and bold. SQL reserved words are green and bold. Functions are pale blue. Numbers are red. Text between quotes are brown. And comments are gray. The last 4 are italics. To speed up the navigation across the text, the application allows using until 10 different bookmarks, numbered from 0 to 9. To add one, you must use the shortcut key Ctrl+Shift plus a digit, and to go to any bookmark, Ctrl plus the corresponding number. The bookmark remains attached to the text and not to the line number. Finally, the application facilitates the codification, writing some statement pattern or auto-completion using a shortcut. These features allow writing an if else, while, do while, function, embedded SQL select, and mail and database configuration statement, reading the first letter and pressing Ctrl+J. Let's see some examples. To run the program, it must be first compiled. This operation puts the code in memory and allows to execute it. While the program is running, the application keeps responsive because the execution runs in background, technically speaking, in another thread. Thus, the user can continue editing the code, but this modification takes no effect until the next compilation. A red indicator appears in the status bar. The user can pause the execution at any time and then continue or completely stop it. There are some other run options, but I will explain them in the next section. As I have already explained it, all commented texts are ignored by the compiler. The application is always connected to one database, which is selected when the application starts, and can be changed at any time. Of course, the language allows to connect more than one database at the same time, but a special variable type must be declared in this case. The application has rich debug tools. I will explain variable watch, variable modifications, function stack, message log, cursors and file watch, step-by-step execution, and breakpoints. Let's start a debug session. In the watch panel, we can see all the variables that are in scope, in the order they have been declared. That means the global ones, the variable declared in the current function and its parameters. The panel shows the name, the type, and its value. In the case of files, cursors, databases, or network types, it shows the state of the variable. For example, cursors appears closed when the program starts and then opened with its raw quantity. The stack panel shows the list of the current function calls. It also includes loop statement of the current function. The exit column indicates the point where the current function or statement will finish. I have included this column to control the program flow while I was developing the language. The system allows to execute the program one instruction at a time. There are two options, step over and step into. The only difference is when they execute a user function. The first one treats it as another statement, but the second one enters in its code. A green triangle appears near the line number, indicating the next instruction to be executed. This instruction also appears in the status bar. When we enter to a function, it is added to the stack, and its parameters are shown in the watch panel. For example, the digiproc main local cursor disappears from the watch panel because it already exists but becomes out of scope. That means inaccessible within this function. When the execution returns to the main function, it appears another time. Remember, the step commands execute a statement, no lines. If there are more than one instruction in the same line, they execute one at a time. The application also allows to see the value of cursors and files. Making click in the watch panel, its content appears in the corresponding tab at the bottom. If the variable is of a simple type, making click of its name in the watch panel allows changing its value. If it is an array, a leaf with all its value appears, and each item can also be modified. You can always see the value of a simple type variable making a right click on it in the edit panel, even if it's out of scope. The application also allows to use breakpoint to debug a program, making click near the line number. There are no limitations in its use, and you can add or delete them at any moment. While the program is running, the application don't update debug panels. If the system encounters an error, it shows it in a Windows message and it's added to the log. In this section, I will explain how to configure the application, how this configuration is saved, how to generate a binary program, and how to improve the database programming using the SQL editor. The configuration forms allow to define the application language and all possible default database connection. There are no limitations in its quantity. For each connection must be indicated the num used to identify it, the database provider, the server name, the database name, and the username and password. The server usually is a remote machine and can indicate its name or IP address depending the database vendor. If the connection is established using ODBC, the source name must be indicated in the server name. In Windows, the application can directly connect Microsoft Access files. The file name must be defined in the server name. all the configuration definitions are automatically saved in a text file with an ini extension in the same directory of the application. This file stores all the connection configuration, the last selected language and connection, and the size and position of the application and each of its panels. When the application starts, it loads all the definitions and saves them when it's closed. If the file does not exist, it will be created. This is the only modification the application does in the computer. Usually, there is no need to modify the configuration file manually, but it's easy to do with any text editor. There is a command to generate binary version of the program that can be executed using the command line application. This allows to deliver a program to customer without the source code. This binary program is generated in the same name and in the same directory of the FLC file, but with the FLCX extension. Finally, the application has an SQL editor to write and test SQL statements before include them in the program. In this section, I will explain the use of the command line executor. FLC programs can be manually executed using the Aconcagua integrated development environment or in a batch way using the Aconcagua executor FLRun. This application needs a configuration.ini file that includes the parameters of the database connection and the location of the message log file. To create this file, you can use any text editor to copy and paste the database parameters. If the log file is not defined, the application will create one in the same directory of the executable. You must indicate as the first parameter the name of the program to execute. If the parameter does not include the extension, the application will first search its binary version .flcx, and if it does not exist, the source code file .flc. Following the file name, you can add the parameters the FLC programs use. And finally, you can also include as parameters the name of the configuration file to use and the location of the log file, preceded with the -a and -l indicator respectively.